This is the algebraic fractions that consist of 2 or more terms. Okay, so again, it's just like regular fractions, but there are variables involved. So let's go back to what we know from our earlier years. Should you have these two fractions, you need to pay attention to what the sum is commanding you to do. In this case, this sum is telling you to add. Okay, it's telling you add the first term and the second term, right, and find out what those two things added up gives you. Alright, so of course you know that you cannot add fractions unless you have a common denominator, which we call an LCD. So you must have an LCD first, and what you know about the LCD is that both these numbers needs to divide into your LCD with no remainder. Okay, and of course in this case, when we look at 2 and 4, the LCD of these two guys would be 4, because 4 divided by 4 is 1, right, and 4 divided by 2 is 2, and so the LCD needs to accommodate both denominators in order for it to be an appropriate LCD. Okay, so here we have the first example, right? We have 1, 2, 3 terms, and the question, the instruction, is to add these two and then subtract this. So I made this red because you need to follow the instruction that the problem is giving you. Okay, addition, subtraction, multiplication, division, they are operations that you must perform. So we need to add and subtract these 3 terms. So of course, just like with the easier fractions, addition and subtraction is not possible unless we have an LCD. So we need to first go find our LCD, and that should be your first step always. So the LCD here is the number that 2, 3, and 6 can divide into with no remainder, and the smallest number in this case would be 6. Alright, so LCD is 6, and of course now our goal is to get all our denominators to be 6. For this one we need to multiply by 3, for this one we need to multiply by 2, and for this one we don't have to make any alterations because it is already 6. So I'm going to do that in the next. Okay, so there is the step where we ensure that our LCDs all give us 6. So I'm going to draw a nice big fraction like this. Okay, and it's going to all be over 6 because that is my LCD, right? And now we just have a look at our numerators and see what is going on. So in the first term over here, we need to multiply x plus 3 with the 3. So we're multiplying 3 and x plus 3. Okay, that is for the first term. And then in the second term, we need to take note of that addition symbol. Okay, and we need to multiply 2 by x minus 1. So we go 2 multiplied by x minus 1. Okay, and then we now need to go ahead and subtract the last numerator, okay, which we will not alter, but that is going to be x plus 1, right? You need to be careful here. We are subtracting the entire numerator, so you need to put that in brackets. And now we just continue and solve the rest of the sum in black ink. So we go as follows. We get 3x plus 9 plus 2x minus 2 minus x minus 1 all over 6. We simplify that as much as we can. We see like terms. 3x plus 2x is 5x minus x is 4x. 9 minus 2 is 7 minus 1 is 6. So that is positive 6 all over 6. Okay, And now at this point you have a monomial. And remember, when we have no monomials, we do facts for fracts. So we need to go see if we can possibly factorize and cancel. Okay, and from the looks of it, we do have a common factor of 2. So we go ahead and we simplify this even further, where we say 2 and then we left with 2x plus 3 all over 2 multiplied by 3. Okay, and now we can get rid of some of these terms, and so the final answer is 2x plus 3 all over 3. And that there is the final solution to this problem. So let's see if we can get the whole sum in. Here we go. So here is the full solution to this example. Please comment any questions should you have them, and thanks for watching.